Hi guys, Sagar here. Hope you understood the previous one. Today we have the third question of exercise 3.4. We need to obtain all the other zeros of this polynomial 3x power 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root 5 by 3 and minus root 5 by 3. So before jumping into this question, let us see an example here. Let's say we have a quadratic polynomial x square minus 5x plus 6. If we factorize this by dividing the middle term and all, the factors you would get are x minus 2 into x minus 3. From this, we would say that 2 and 3 are the zeros of this quadratic polynomial. So, another thing we can conclude from this is x minus 2 is a factor of the quadratic polynomial, and x minus 3 is also a factor of quadratic polynomial. So if I divide the quadratic polynomial by x minus 2, if I say that 2 is the zero of this quadratic polynomial, find the other zero, I would divide the quadratic polynomial by x minus 2 and the quotient is what I would get x minus 3. So by dividing a quadratic polynomial by one of its factors, the quotient will be the other zeros of the polynomial. So if we use the same concept in this problem, so question number 3, they told us root 5 by 3 and minus root 5 by 3 are the zeros of this biquadratic equation. So if I write them in factors, so this would be x minus root 5 by 3 and the second one would be x plus root 5 by 3, right? So I'm going to divide the biquadratic equation with this 2. Instead of dividing it 2 times, I'm going to multiply these two expressions and divide it at the one at the same time. So we have x a plus b into a minus b here. So it would be a square minus b square. So this would be x square minus 5 by 3. Right? So if I divide the given biquadratic equation with x square minus 5 by 3, the quotient which I would get would be the other zeros of the polynomial, right? So let's see. So we have 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. We need to divide with x square minus 5 by 3. So as I told you before, the how do we divide? We have three steps. First, we need to see what the term that's need to be multiplied to the first term of the g of x, that's the divisor, to get the first term of p of x. So I would multiply 3x square, right? So if I multiply 3x square to the first term of g of x, I would get first term of p of x, right? So 3x square into x square is 3x power 4 and minus 5 by 3 into 3x square is minus 5x square, right? So 3 would get cancelled and this would be 0x cube, right? Next step is we change all the signs. This would be minus, this would be minus, this would be plus, and now add. So this should be 0. 6x cube minus 0x cube is still 6x cube, and minus 2x square plus 5x square is 3x square. So right, so this should be 3x square. I'd bring this down minus 10x. So next, what would I multiply to the first term of g of x to get first term of p of x? Now I would multiply 6x, right? 6x I would multiply. Next, if I multiply and write all the terms of, so 6x into x square is 6x square, 6x cube, sorry, and minus 5 by 3 into 6x. So if I write it beside here, minus 5 by 3 into 6x, this will cancel two times, so it would be minus 10x, right? So this would be minus 10x and this would be 0x. Now change the signs, minus minus plus, this would get cancelled, this would be 0x square, so 3x square, so plus 10x minus 10x would be 0, and last we have minus 5 here. So next, what would I multiply? I would multiply 3, so plus 3. So x square into 3 is 3x square, and minus 5 by 3 into 3 is minus 5. So this would be minus 5. Now change the sign. This would be minus, this would be plus, and if I add, I would get 0. Since Minus root 5 by 3 and root 5 by 3 are the zeros of the polynomial. When we divide the polynomial with the factors, we get remainder as 0. So the second part of the question, the quotient are the other roots of the polynomial. So the quotient we got is 3x square plus 6x plus 3. So let's write it below. 3x square plus 6x plus 3. It's equated to 0 to find the roots. So we can take 3 common here. X square plus 2x plus 1. This would be x square plus 2x plus 1 equal to 0. Now I would divide the middle term. So this would be x square plus x plus 1 equal to 0. Next I would take x common here. This should be x plus 1 and 1 common here. This should also be x plus 1. And if I take x plus 1 common here, x plus 1 into x plus 1. So the other zeros are, this should be, if two numbers multiply to get 0, either of the two numbers should be 0. So x plus 1 equal to 0 or x plus 1 equal to 0. Therefore x equal to minus 1 or x equal to minus 1. So the other two zeros of the biquadratic equation, the biquadratic polynomial they gave is minus 1 and minus 1. So I would write the therefore statement as, if minus root 5 by 3 and plus root 5 by 3 are zeros of this given quadratic polynomial, biquadratic polynomial, then the other two zeros are minus 1 and minus 1. That's it. Hope you understood the question. Subscribe for more such solutions. Thank you.